Welcome to today's lecture. Today we'll be looking at balancing redox equations in alkaline medium. Our previous lecture was on balancing redox equation in acidic medium. I would want you to find that lecture and go through it. It will help you to understand this one better. The topic again is balancing redox equations in alkaline medium. The redox equation before us to be balanced is CrO42 minus tetraoxochromate 6 ion, SO32 minus trioxosulfate 4 ion, chromium ion plus tetraoxosulfate 6 ion. So take these steps. I would like you to follow through so that you get how to eventually do yours. Step number 1. Separate the redox equation into two half equation. And that is CrO42 minus will give us Cr3 plus, SO3 2 minus giving SO4 2 minus. Step number 2. Balance all other atoms except oxygen and hydrogen. That is, as you balance every other atom, do not touch oxygen and do not touch hydrogen. Here we have one atom of chromium, one atom of chromium. So it's balanced. We write it out. Here we have one atom of sulfur, one atom of sulfur S. So it's balanced. We write it out. Step number 3 now. For every atom of oxygen lacking, add 1 mole of water to the deficient side. So here we have 4 atoms of oxygen, and that will inspire us to write 4 moles of water to this other side. We add it because it is deficient of hydrogen. Here we have 3 atoms of oxygen, and here we have 4 atoms. So this side is deficient of 1 atom of oxygen, so we'll add 1 mole of water. Step number 4. For every atom of hydrogen lacking, add 1 mole of hydrogen ion to the deficient side. And so here we added 4 mole of water. The addition of 4 mole of water has introduced 8 atoms of hydrogen. That is 4 times 2, 8. And so we'll add 8 mole of hydrogen ion to the deficient side. That is the left hand side that is deficient of hydrogen. Here we added 1 mole of water. This has introduced 2 atoms of hydrogen to the second half equation. So we add 2 mole of hydrogen ion to the deficient side. Step number 5. Add equal mole of hydroxyl ion OH minus to both sides to neutralize the H plus. Okay, and I want you to also note that H plus OH minus will give us water. We're going to use this later. So we have H plus, 8 H plus. And so we add 8 OH minus to the left hand side. And we also add 8 OH minus to the right hand side. Now, this is the second half equation from step number 4. And so we have 2H plus here. So that means we'll add 2 OH minus to the right hand side, and we'll add 2 OH minus hydroxyl ion to the left hand side. Step number 6, simplify the 2-half equations. And so then the 8H plus the 8OH minus will give us 8H2O. Don't forget, we did the replica here, H plus OH minus, giving us H2O. So then 8H plus 8OH minus will give us 8H2O. Likewise, when you come here, 2H plus 2OH minus will give us 2H2O. But I want you to look at something. We have this, 8H2O. On our right hand side, we have 4H2O. So we take this 4H2O to this other side. Since the number of mole of water here is greater, so we take the 4 to this other side. So 8H2O minus 4H2O, that will give us 4H2O. So finally we have CrO42 minus plus 4H2O, giving us Cr3 plus 8OH minus. Now, if we look at the second half equation here, if you look at it here, having added the OH, we had 1H2O here. So if we take the 1H2O to this side, don't forget the 2H plus the 2OH minus will give us 2H2O. And then the 1H2O that was here we transfer to this other side. That gives us minus H2O. Eventually we have SO32 minus plus 2OH minus, giving us SO42 minus plus H2O. I would like you to listen carefully. Step number 7, balance the charge by adding appropriate electron to the more electropositive side. And so here, the charge here is minus 2. You can see minus 2 there. This is not in the ionic state, so it's 0. The charge here is plus 3. This is minus 8. By the time we resolve these two, I'm going to get minus 2 and minus 5. This side is more electropositive, and so by how many? If we do minus 2 minus 5, that's minus 2 plus 5, that will give us 3. So this side is more electropositive by 3. So we add 3 electrons to the more electropositive side. Normally we do the more electropositive side minus the less electropositive side in order to get the number of electrons to be added. We take up the second half equation, SO32 minus plus 2OH minus, giving us SO42 minus plus H2O. Here we have 2 minus, that's minus 2. This is SO3, okay, minus 2. Here we have minus 1, but we have 2 of it, so that's minus 2 again. That will give us minus 4. Here we have minus 2. The water is not in the ionic state, so that's 0. That gives us minus 2. So it means that the minus 2 here is more electropositive than the minus 4, and by 2. So we add 2 electrons to the more electropositive side. Then we use the integer here. That is, we have 2 electrons, so we use integer 2 to multiply the first half equation. And then we use the integer 3 from the first half equation to multiply the second half equation. If you look at 2 of them, they are not factors, so we cannot cancel. So by the time you multiply, here, if you multiply, you're going to get 2, that will take us to step number 8, multiply the 2 half equations to cancel out the electrons. That is, multiply the 2 half equations by appropriate integer. Now I omitted that, by appropriate integers to cancel out the electrons. So I do 2 times CrO42 minus, that will give us this. 2 times 4H2O will give us 8H2O. 2 times 3 electron, that gives us 6. 2 times CrO3 plus will give us 2 CrO3 plus. 2 times 8OH minus will give us 16OH minus. Now, in multiplying the second one, we have to make the second half equation fit in properly, to align properly with the first equation, first half equation. So, if you look at it, we're multiplying by 3. So 3 times SO3 2 minus will give us 3 SO3 2 minus. Now, if you look at, we have water on this side, so we will need to transfer this water to the other side. So 3 times H2O will give us 3H2O. So as we move it to this other side, it becomes minus. Electron is on this side for the first half equation, and on the second half equation, the electron is on the right hand side. So by the time we multiply, we get 6 and move it to the left hand side, so it becomes minus. And then 3 times SO42 minus will give us 3 SO42 minus. And then 3 times the OH minus, don't forget it's 2, that will give us 6. In the first half equation, the OH is on the right hand side, so we move the 6OH2 minus that we got by multiplying by 3, we move it to the right hand side, so it becomes minus. And finally, we get our balanced redox equation in alkaline medium. And so we write 2 CrO42 minus plus 3SO3 2 minus plus, by the time we resolve this, 8 minus 3, that gives us 5H2O. The electron is cancelled now. Then 2Cr3 plus 3SO42 minus 16OH minus 6OH, that gives us 10OH minus. And that brings us to the final balanced redox equation in alkaline medium. You will need to listen to the video 1 or 2 more times in order to be able to get the concept. So this is how to balance redox equation in alkaline medium.